Hello guys, welcome to SKMM3242 Measurement and Instrumentation. This is chapter 1 on the introduction to measurement and instrumentation system. My name is Dr. Kamarul Hafizam bin Ismail. I'm going to be with you for the whole lectures. We have here 14 lectures that will very much cover this subject. All right. So now that we are talking about instrumentation and measurement, if you have any idea of what is measurement actually, or even what is instrumentation, okay. So what I can say is basically measurement is kind of activities that we do to indicate a certain quantity or certain parameters that um, we want to know or we want to measure. For example, we are looking at an object, flying through, and want to know what is the speed, for example. So we measure the speed. Or suddenly during the day we are feeling, very hot. We get sweat and all that, and suddenly it gets cold. We want to know what is the temperature, for example. So we do this measurement, okay, or even not limited to temperature and speed. We want to measure almost anything or everything that we can feel out there. Uh, Another example, maybe pressure, maybe velocity, maybe weight or certain things and all that. So uh, measurement system is basically needed to measure this thing. All right, to indicate certain thing. All right. Um, of course, when we measure something, for example, temperature, we don't really say that today is 27 what. So you may come to this kind of question. That's why we always accompany a number that describe measurement with some units. For example, here we have length. When we want to describe length, the time, the mass, the temperature, we always describe unit. You may have seen this in your previous uh, encounter with the system of education. You may have known meter for is a unit to describe length. Kilogram is a unit to describe mass. All right, and and we are using seconds to describe time. All right, so this is basically the basic unit, and after that we have the derived unit. It is derived from the basic unit, but it becomes something different. For example, um, we can use meter square to describe the area of certain things. We can use meter cubic to describe volume. We can use meter per second to describe velocity. We can use meter per second to describe acceleration and so on. So we have basic and we have derived unit, and throughout the whole process, you will be engaged with a lot of measurement unit, which from there you need to understand. When I give this kind of kilogram per meter per meter or per second, you know what I'm talking about basically. So now we know what is measurement system and it what is in the measurement system itself. All right. So, but to be able to achieve measurement in order to measure something, we need uh, what it is called instrumentation, the instrument. So basically, the instrument is basically the devices or the tools that we use to measure or to perform the um, activity or process in quantifying the the parameters that we are looking for. Basically, for example, we want to measure the temperature. We use thermometer, for example. So thermometer is basically the instrument that we are working with. All right. So I can basically use many kind of system of instrument to measure different kind of quantities. For example, here I have with me is a vernier caliper, which is very much used to measure, length of any object. For example, here I have this mount with me, so I can use this kind of caliper to measure the length of dimension of this object, for example. Right. So also I have with me different instrument to measure the wind speed. So this is the sensor here that do the spinning when the wind blows through it. Then it will give you the display in terms of meter per second in the display unit. So these are the instruments that we basically use, and of course I have also here with me, as you know, this is the multimeter. So also the instrument that I can use to measure voltage, current, the frequency, the what they call that, impedance, and many others. So these are just instruments that being used to perform measurement. Okay. So for example, in the you can find system of measurement. You can find instruments in many applications. For example, here in automotive, you can have oxygen sensor, you can have airflow sensor, you can have water temperature sensor to measure the coolant temperature. Even in the engine, in the combustion system, you have fuel coming out to the system, so you have to understand. You have to know what is the pressure of the oil, and of course you have CO2 sensor, and you have accelerometer. These are the system of instruments that install in a car basically to perform those measurements. Okay. Also, you can find the same thing in the system in the biomedical area. So, do you find any instruments in this object, in this picture and in this photo? All right. So, bear in mind we are looking at quantity to be measured and tools that do the measurement. So, because I cannot see any from this photos. All right. So here we have quantities to be measured, and you have instrument that do the measurement. So this is a system of instrumentation. Usually this is pressure. This is all the other example of how they use system of measurement. But why do you think we need system of measurement and instrumentation? Why is it so important? Okay, in some what they call that application, for example, in the industry, it's very crucial that we use automation in monitoring and control of any process in the industry. Okay, for example, we want to measure the temperature in a room, so you cannot be having human to go in and always check progressively until we reach a certain temperature. So by using instrumentation system, you can plug in one small sensor in the room, and you can monitor from far. So the whole process is basically monitored, and of course, if you were to have a human going into the room and do the measurement by themselves, they'll more or less estimate the temperature according to their experience. But by using measurement and instrumentation tools, you can precisely measure up to like 2 or 3 floating points. For example, 27.001 degrees Celsius, for example. So by having this kind of information, you can produce a much more better and quality products. And of course, for safety purposes, in some environment, which is not safe for human, for example, nuclear radiation, high temperature, high current. You cannot have human to go very close to do the monitoring or to do the measurement. So you can use these devices to do the measurement for you, so that you can have the readings from remote, for example. So this is why basically you need a system of instrumentation. This photo or this slide basically shows how laser sensor is being used to sense the thickness or diameter of a wire. Of course, without the system of instrumentation, you cannot have human being to measure this thing by themselves. You will find it different throughout the thickness will be different throughout the process. So if you use this kind of system, basically you can ensure the consistency of the reading, and you can always ensure that the thickness of the wire of this particular wire is the same and standard for all distances. Here is also again instrumentation of sensor that they use to measure wire thickness, and this is also a good example of the same application. Now we are looking at the system of instrumentation. What is actually inside the system of instrumentation? So this diagram shows there are 4 blocks here. In any system of instrumentation, you may want to find these 4 things inside. If you cannot find these 4 things, meaning that the system is not the system of instrumentation. Okay, so the transducer on your left is basically some kind of sensor. They converts some values, the real world parameter, for example, speed, temperature, pressure, heights, weight of anything. Those are, I would say, analog or environmental parameters that you are measuring. So the transducer basically converts whatever they sense they detect, into electrical kind of value. Okay, useful value, we say it here. And after that, the value is being fed into a signal conditioner. The value may be small, maybe too small. The value may be too big. The value that came out from a transducer maybe as of different formats. All right, so we need a signal conditioner to recondition the signal so that the signal can be channeled to the next block, which is the A to D and the display. So A to D is basically converts the signal to the digital from the analog world. So transducer and signal conditioning block is actually analog block, and the display is usually will be the digital block. Okay. So for sensor, because by definition sensor here converts the measured value into another useful value. So most of the time when you speak about sensor, they converts from environmental parameters to some kind of electrical parameters that we can measure. For example, here you have thermocouple. They measure input in terms of temperature, and they give you output in terms of EMF. EMF is some kind of voltage. All right. And the next example is resistance thermometer. Also the same device as thermocouple they use, they measure temperature, but the output is different here. Thermocouple give you voltage, but thermometer or resistant thermometer give you resistance, ohm changes. All right. So 2 different sensor read the same parameter, temperature, but they can give you different output. This is very much depend on your design of system of instrumentation. If your design takes voltage, so you have to use, if your design takes voltage as an input, you have to use the thermocouple. But if your design takes resistance change as your input, you have to work with resistance thermometer. Okay. And also the next block will be the signal conditioner. Again, the signal that came out from transducer may be weak, maybe too strong, maybe of different format. So you need signal conditioner to basically change or recondition the signal so that the next block is able to read it. Okay, for example, if the input is too small, we can use amplifier to amplify the voltage so that it can be big. For example, the input I receive like in nanovolts or microvolts, but my next block is only able to read in millivolts or in volts, so I have to amplify it. Okay, if the sensors that I'm working with is basically giving out resistance as the input, so they give changes in terms of ohm, so I need to use a Wheatstone bridge so that I can convert the ohm, the resistance change, to the voltage change. So after that, I can use amplifier. If the voltage change is small, I can use amplifier to make it bigger. Okay, so display, is very easy to detect. For example, you have your weighing scale when you You get up into a weighing scale, you can see the meter going, is changing and start giving you reading. So those are some kind of display, but in the analog form. And of course, you can always find a display in digital form, which is in terms of LCD and all that. For example, here I have the wind speed sensor. I have the sensor here. I have the transducer. I have the signal conditioning system A to D, and of course, I will have more or less the digital reading there. If I blow into the sensor, you can see the reading is giving out in digital form. So this is a good example of system of instrumentation. Okay. As for the last remark here, I have some example to show you so that you can see this introduction in a much more clear picture. Okay, I have with me analog vernier caliper. Okay, you can do the measurement of length and all that. You have scale here so that you can take the reading. I have another version with me. This is also the same vernier caliper, okay, but with a digital display. Okay, can do the same job just now as the analog one. Okay, but this is just a measurement tool. Okay, this is not a system of instrumentation, but this is a system of instrumentation because you can find sensors. You can find the sensors, you can find signal conditioner, you can find ADC, and of course you can find the display. So this one, we have 4 blocks in this device, and this device we have nothing. So this is just a measurement tool. It is not a system of instrumentation, but this is. All right. So with that, I end the lecture 1. Thank you very much. I'll see you again.